Unit 3. What happened to Unit 2? I skipped it because, Matt, when we brought in Flex, something had to go, and so that's what went. You're going to learn that in physics, every measured quantity is one of two things. It's either a scalar or a vector. And anytime I teach you something new, you'll need to memorize what that is. I thought you said, Mr. Dueck, you don't like memorizing stuff. Sometimes there is some stuff you have to memorize, but I wouldn't freak out about it. Like, you're not going to have to make flashcards or anything. You will just naturally memorize what's a scalar and what's a vector, because we'll just keep referring to them as by what they are. It'll just happen and take care of itself pretty much. What's a scalar? A scalar is a quantity that has magnitude only. And then it says, for example, I'm going to give you an example in just a second. Vectors have both magnitude and direction. Vectors have magnitude, size, and direction. Scalars have magnitude only, but scalars have no direction, much like your futures. Oh, that came out wrong. Scalars have magnitude only. Vectors have magnitude and direction. Put your pencil down, look up. Oh, I got to pause the video. So what are some examples? Time is a scalar. What time is it, or how long did it take? Adding a direction doesn't even make sense. Speed is a scalar. You'll learn that. Mass is a scalar. What's the mass? 28 kilograms. It doesn't make sense to say 28 kilograms north. 28 kilograms. Distance is a scalar. Voltage is a scalar. Work is a scalar. Energy is a scalar. What else is a scalar? There's lots out there. I'm not going to list them all. What are some examples of vectors that have a direction? Force is a vector. A force is a push or a pull. It makes a difference which way you push on something, because pushing on it from a different direction will cause it to move in a different direction. You'll get a different result. Force is a vector. Velocity is a vector. Mr. Dueck, I thought you said that speed was a scalar. Speed is different from velocity. They're related, but different. Acceleration is a vector. Makes a difference whether you're speeding up or slowing down. If you're accelerating forwards, you're probably speeding up. If you're accelerating backwards, you're probably slowing down. Electric field is a vector. Magnetic field is a vector. Current is a vector. Lots of stuff. Torque is a vector. Lots of stuff is vectors. We're just going to do a little comparison. Now, in physics, we're going to tend to abbreviate. So what would be a good letter to use as an abbreviation for time? What would be a good letter to use as an abbreviation for time? Anyone. I'm trying to give you a hint in the way I'm pronouncing it. Okay, so I'm going to write this. Time, comma, lowercase t. From now on, whenever I write a lowercase t by itself, you'll see time. And you don't need to memorize that. You will. It'll just happen. Acceleration is a vector. A good letter to use for acceleration would be, any guesses? Acceleration. Okay, lowercase. So I'm going to go ACCL period, comma, A. I figure if I type Excel, you'll clue in the rest of the word. There are two that are very related. Speed, for example, 30 meters per second, that's a scalar, versus velocity, 30 meters per second north. That's a vector. Has a magnitude 30 and a direction north. Now, in physics 12, we often start using compass directions. In fact, we'll talk about 28 degrees west of south. In physics 11, typically we'll use positive for forwards. And what would be a good thing to use for backwards then? What's the opposite of positive? Negative. We'll typically do that. We won't often write north or south or east or west because physics 11 is mostly one-dimensional. Physics 12, we start to go two-dimensional. There are others. One more I need. Mr. Dueck. Yes, Matt. Can you give me a dumb way that I can remember that speed is a scalar? Mr. Dueck, can you give me a stupid way to remember that speed is a scalar and that velocity is a vector? There's got to be some way that I could remember that, Mr. Dueck. I'm a terrible teacher, Matt. I got nothing. I can't think of anything. So you'll just have to come up with something, some way on your own to remember that velocity is a vector and that speed is a scalar, because I can't think of anything. Distance, 48 meters versus displacement, negative 48 meters. That would mean that you'd ended up 48 meters behind where you started from, or below where you started from, depending on the question. Distance and displacement are the two trickiest ones, because I got nothing for that in real life. Because not only do they both begin with the same letter, they both begin with the same two letters. No, they both begin with the same three letters. But we'll do it enough times that you probably will just memorize which one's the vector and which one's the scalar. It'll take care of itself. So I don't think you'll need to make little flashcards or anything like that. Vectors are either written in bold font. In a textbook, they would write, for example, acceleration in like a bold font, but that's really tricky to do when we're handwriting. So the symbol for a vector when we're handwriting is we put an arrow above the letter, although since we're lazy, you'll notice over the years it's become just a half arrow. We don't even bother putting the bottom pointy part of the arrow. So up here where I wrote a letter A, because that's irking me, can you put a vector symbol above that? Because that's acceleration. What would be a good letter to use for velocity as an abbreviation? So here's where it gets a little tricky. That's velocity. How do I know? Not just because of the V, but there's a vector symbol. Look up. That's speed. There's no separate symbol for speed. It's velocity without the vector symbol. It's the magnitude only. Velocity, speed. Velocity, speed, velocity. I will not take marks off if you do incorrect vector notation. However, you might just naturally lose the marks by doing incorrect vector notation because you might be doing scalar math when it's a vector, or you might be doing vector math when it's a scalar. And it turns out, Mark, the rules are a little bit different. Preview of coming attractions. Let's talk about distance versus displacement. Next page over. Distance is how far an object has traveled. The correct symbol for distance, technically, Isaac Newton liked to use a lowercase s from a Latin word. And in Britain, they still like to use that one. cross it out. It looks too much like a number 5, and it looks too much like the units for time, which is measured in seconds. So if you're in Britain, that's what you would use. Technically, the correct variable that I should use for distance, the one if you take physics in university and post-secondary, almost every course will use, is an x, because they want you to imagine you're on the x-axis of a graph, moving to the right and moving to the left, moving to the right and moving to the left. And I've almost considered using that letter because it is what you'll see in post-secondary school, Caleb, but I don't. So we're going to cross that out. Mr. Dueck, how the heck do you cross out an X? That's very meta. I don't know. You know what letter I'm going to use for distance? Lowercase d. This is wrong. Right now, a university prof would be cringing at me and saying, what are you doing? First of all, most of you are not going to be taking post-secondary physics, so I'm not freaking out. And it's easy to remember D for distance. But some of you will take calculus next year, and you'll learn actually a lowercase d has a hugely important meaning in calculus. You know what? I'll help you keep straight which one is a distance and which one is a derivative in calculus next year in calculus if you need it. It's easier to remember that D is distance. What are the preferred units for distance? Meters. Sometimes we'll use kilometers, especially if we're looking at cars, because cars' speeds are typically given in kilometers per hour, but for the most part, meters. Displacement. That's an object's change in position. I apologize for those of you watching it on YouTube right now because I'm doing a classroom demonstration and you can't see, but I'll talk loud. The rest of us, let me illustrate the difference between distance and displacement. I'm going to stand right here and let you imagine this is 0. And let's imagine that each step that I take is exactly 1 meter long, just to make the math nice. Count with me. 1, 2, 3. What's my distance? 3. What's my displacement? 3 to the right for those of you at the back of the room, although I'm not to your right. You know what? Positive 3 would be a good way to describe it because that's the positive direction on the x-axis. Okay. Back to 0. Count with me. 1, 2, 3. How many steps did I take? 3. What's my distance? 3 meters, because that's how many steps I took. But what's my displacement? Not 3. What's my change in position? Positive 1. Positive 1. Okay? That's my change in position. That's my displacement. Displacement doesn't care what you did in between to get there. It asks, where'd you start? Where'd you end up? What's your change in position? We're going to do one more. Count with me. 1, 2, 3, 4. What distance did I travel? 4 meters. What's my displacement? 0. 0 is a bit unique because you can't really give a direction for 0. Positive, negative, 0. Oh, that one you don't need to put a direction next to. I'll figure out back where you started from. Is that okay? Symbol. Well, S with a vector sign over it, but I'm not going to use that. X with a vector sign over it, but I'm not going to use that. You know what? I'm going to use that. It's also measured in meters. Sometimes when objects start to move, it's useful to be able to describe their location. Often we'll use an imaginary number line the same way I had you just counting in front of you and you were kind of imagining a little number line there. We'll use an imaginary one, or we'll give you one in the diagram. Usually it'll be an imaginary one because these are a pain to do in Word. Graphics suck in Word. So To describe location, you can imagine a meter stick is placed next to the object. The meter stick acts like a number line. Objects to the right we'll call positive. Objects to the left of 0 we'll call negative. That's not a hard and fast rule, by the way. Once or twice this year, we'll say, you know what? It's going to be easier to let to the left be positive because it's going to make the math nicer. Sure. As long as you change your frame of reference, you'll be okay. Anyways, example 1. A bug walks along a number line. It starts out at location A and goes to B. Then it turns around and walks to C. A says, what distance did the bug walk? Josh, you awake? Because I saw you kind of doing a little head shake there. You're good? By the way, if I haven't told you already, if I sense you're zoning out, I'm pretty good at spotting that. Be prepared for me to call on you not to be mean, but it's an easy way to get you to zone back in and you'll get the adrenaline rush and you're back in the class. So Josh, what distance did this bug travel if it started here, went here, and then went there? How far from here to here? You have the paper in front of you. You can be looking at the paper in front of you. Okay, so you ready? How far from here to here? Say it loud and proud. How far from here to here? Do the math in your head. Don't say 6. Starting at 4. Going. No negatives. This is distance, not displacement. So no negatives. So you ready? So what? So ready? How far? How far? Total distance in your head? Yeah, you're overcomplicating it, right? Let's write that down in our notes. In your homework, if you can do it in your head without writing all this out, I'm fine. But what Josh did was he went 4 plus 10 or 10 plus 4. We would say the bug walked 14 meters as a distance. That's what you're most used to when you think about how far did we walk. So for example, if you ever go for a walk for exercise, you almost always end up right back where you started from. Your displacement is 0. But you don't think that, it's a nice 5K walk. You think to yourself. Depends on whether you're using distance or displacement. What's the bug's change in position? What's the bug's displacement? We started here. We ended here. Sahara. -6. You could also say 6 meters left. Or you can say -6, which is easier to write. So I'm almost always going to use negatives and positives. Don't write this next bit down. Look up. I would take a half mark off if you did both, because what's negative left technically? I'm looking for a word that starts with the letter R. What's negative left technically? Right. So don't do both. You can also do that. I'll give you full credit. But most kids say, I'm naturally lazy. I'll do that. Turn the page. Behold, 3 paths. Path 1, path 2, path 3. Along which path or paths would your distance be different from your displacement? I'm going to reverse the question in order to answer it. Only one of these paths has the same distance and displacement magnitude. Which one? Yeah.
Path 2.
Why?
Because it's a straight line.
All lines are straight, Captain Obvious. That's why they're called lines. Why? Sorry, you walked into that one. I'm a math teacher. Yeah. Straight line. You realize if it wasn't a line, if it wasn't straight, it wouldn't. Like, lines are straight. That's why we call them, lines. Mm-hmm. It's like saying it's a dark black object. The dark is redundant if you use the word black. That you've taken care of that. Mm-hmm. Okay. Yes, I totally agree. So the two that don't, those two. Here, the distance would be the blue path. The displacement would be the straight path, the linear path, if you want to sound really nerdy. In path 3, the displacement will be the straight path. The distance would be that little curvy thingy. Okay. So you're kind of wrapping your brain around the difference between distance and displacement. The only tricky part to me is not the math, it's the fact that they both begin with DIS. Kyle, keep them straight. And I'll just try and throw lots of practice over the next couple of weeks and we'll keep them straight. We can also give positions using positives and negatives. It says use the number line below to give the positions of the objects. Don't forget the units. Okay. What's the position of the heart? I would like magnitude and direction. So what's the magnitude of the heart's position, Mark, my friend? And direction, positive. You know what? This is one of the few times where I might actually put the positive sign in just to remind myself I took care of the direction. Now, if you don't put a plus sign in front of it, I'll assume it's positive, and I'll give you full credit. But just that's my, oh, I did do the direction. Check. What's the position mark of the diamond? I think you're right. I couldn't hear you. Did you say -4? Yeah. Or you could write for part 1, 4 meters right, and you could write 4 meters left. What's the position of the cross? 0, and you can see it's tough to give a direction then because it's neither positive nor negative. I said to you that a displacement was a change in position. We can use arrows to represent a displacement. So here's a bike moving along a number line from +4 meters to -3 meters, and you can tell that it's in that order because the arrow tells you the direction of motion. We will often use a variable, x or d, to symbolize an object's position, and we'll use subscripts, I for initial and f for final, to show the initial and the final. So if I was labeling this, for example, I might call this either x final and x initial, or I might call it d final and d initial. One thing for those of you in the back corner, Paige and Mark, if I'm doing an initial, if I'm doing a lowercase I will always put a little curly tail on it so you can tell that's not a 1, because from the very back you might not be able to see the dot on the I. So if you ever see that, that's D1, not DI. If you ever see this, that's DI, and the dot either didn't work on my pen or you just can't see it because I did it small and you're in the back corner. Okay? Just something I started doing a few years ago because I had kids ask me. Next page. Example 4 says, draw an arrow that shows an object moving from the -4 position to the +5 position. Okay. I can do that. I'm going to put a little dot at the -4 position, and I'm going to call that DI. Oh, it's a vector, so I'll put a little vector sign above the D. The I is for initial, D for displacement. Kyle, where'd we end up? Are you positive? Shut up. Okay. There's DF. And if I wanted to show the direction of motion, I can do that. By the way, this is an inefficient way to do things. Drawing pictures and things. We'll do this all mathematically soon because it's way easier to write this all with numbers, zip, zap, and go. But to wrap your brain around the concepts, we'll draw pictures and stuff like that. So what is this object's distance? Kyle, what is this object's distance traveled? Thank you for sticking in the units. What is this object's displacement? I'll show that it's displacement by putting the vector symbol on it. What's the magnitude of this object's displacement, of this object's change in position from where it started? Still 9. Which direction has this object traveled, Kyle? To the left or to the right? How could I show that? I could write the word right, I guess, but what's a shorter way to show to the right? It's so obvious. Help them out. Are you positive? Yeah. Okay. So you could say 9 meters right, I'd give you full credit, or you could just say positive 9 meters. And in fact, if you didn't put the plus sign there, I'd assume you meant it to be there. In this case, the distance and the displacement have the same magnitude. Draw an arrow that shows an object moving from 7 to 1. Okay. Here is my initial location. Here is my final location. Cool. Cool. Ethan, what's this object's distance? How far did it travel? Where did it start at? 7. Where did it finish at? So what's its distance? Bigger minus smaller, right? Units? Units. Sorry? Yep. Oh, sorry, I put a vector sign. Distance is a scalar. D equals 6 meters. What's this object's displacement? Same magnitude, 6, but what direction? Ah, good. Yeah. Now, so far, I've been giving you numbers less than 10 on a number line. We're going to come up with a more mathematical equation-y way to solve these page because I want to do examples that are more real-life-ish as opposed to this made-up stuff. But okay, we're doing terminology right now. So distance versus displacement. Distance, how many steps did you take in total? How far have you traveled? Displacement, how far did your position change from where you started from? Who cares what you did in between? Displacement is the vector. There should be a directional component. Speed versus velocity. Average speed is defined as the change in position, the change in distance over the change in time. How do we pronounce that triangle? Well, you can say delta if you want to nerd out, Amy. You could read this as delta D over delta T. But you'll notice I never read that. I used 2 words. What's that triangle an abbreviation for? Did you hear it? Yep, loud and proud. You're right. Change, 2 words. Change in. As an equation, so we're usually interested in velocity, which begins with which letter? We're usually interested in velocity, Mark, which begins with which letter? Speed is the scalar version, so I'm going to write V without a vector sign. That's the abbreviation for speed. Please don't use S as an abbreviation for speed. That is taken by something else, okay? How do we pronounce that? Delta? Caleb, what's change in anything? I always ask if someone knows. What's change in anything? Does anybody know? If you look at your green sheet in the top right corner, I think first of all you'll see in the top right corner that I've told you that that triangle does mean change in, but I think you'll also see I've told you that change in anything is always something minus something. Caleb. Say it again, what? So that means that if I want to turn this into an equation, it's going to be d final minus d initial all over, and then look up. Don't write this next bit down. I should technically, don't write this down, write t final minus t initial because time is a change in as well. But time shows up all over the place. And time, because it's always a change in, we get lazy. We understand it's a change in. We just put a time there because there's no way to find to find time. You have to start a stopwatch and stop a stopwatch, and there's no other way to do that. So we just get lazy over the years. We've stopped putting deltas in front of the t. You'll see there's one other variable in physics 12 where we do the same thing. Voltage. What would the units be? Caleb, What are the, first of all, there's a fraction line. Let's draw a little fraction line. Caleb, what are the units for distance? Oh, you figured out the whole thing. He said, Dueck, it's got to be meters over seconds, because on the top it's meters, on the bottom it's second. One of the things that I'm going to encourage you to do is memorize what units go with what concepts. Mr. Dueck, I thought you hate memorizing. Yeah, I do. So if I tell you that it's worth memorizing something, it's really worth memorizing something. I wasn't going to go like that, but Angeli was yawning, and so I had to cut her off mid-yawn there. It's really, in fact, what you're going to be doing in Physics 11, you're doing a lot of word problems. Not the stupid ones you do in math that are so poorly designed. You're going to find actually Physics 11 word problems are way, way, way easier. And one of the things I'm going to teach you, Matt, is you scan the question for units, not for numbers, because the units tell you all the stuff that you have, and you'll almost always see something flash into your mind. Oh, I can do this. So it is worth memorizing units. Last question, folks. Speed. Speed. Scalar or vector? Speed. Scalar. Okay. I want to compare that with, turn the page or next page over, average velocity. That is change in displacement over change in time, where that delta is change in, and Caleb, what's change in anything? That's going to be your cue for a while, so just be ready, okay? That'll be your line. So as an equation for average velocity, oh, by the way, one more thing, sorry, can you go back one page here? This is average speed. My abbreviation for average speed, I do a little subscripted AVG, and I think I might have put that on your formula sheet somewhere. I can't remember. We'll check in a second. The average. The average. I could put AVE, but for some reason I put AVG. So average velocity here on the next page, I'm going to use V, but with the vector symbol for velocity. And that's going to be final displacement minus initial displacement over time. Or, you know what, since displacement is a change in position, it's just going to be the displacement over time, because you would have done that when you calculated the displacement already. You would have said, where did I start? Where did I finish? What's my change position? What are the units for this? Oh, you know what? It's also meters per second. Velocity, scalar or vector? Is there a dumb way that I can remember that velocity is a vector? I got nothing. Wow. I'm a terrible teacher. Remember the bug? Josh, we're coming back to you now because you gave us the 14 as an answer earlier. If the bug's trip that I mentioned earlier took 30 seconds, what's the bug's average speed? Well, average speed is going to be, really, it's the distance over the time. What was the distance that the bug traveled from the previous page, Josh? Or you might remember it. If not, you'll go back and look at your notes where you wrote on the previous page. I don't know. That's okay. Take your time. Oh, Ethan's whispering in your ear. What? And then, according to this question, how much time did it take the bug, Josh, in seconds? It gave you the... You need to now read this question, example 6. You're doing good. You're good. Look up. Okay, and now you're going, oh, obvious in hindsight. How many seconds? Say it again, loud and proud. Good. Hey, what's that on our calculator, folks? By the way, 14, how many sig figs? 2. 30, how many sig figs? Don't say 2. 1. Technically, Marcus, how many sig figs should I go to in my final answer? I'm going to ignore that. I'm going to go to 3. So give it to me to 3 sig figs, something, point, something, something. Or no, point, something, something, something. Is it 4 and then the 6 repeats? Yes, so we'll make that a 7. Now, if you haven't already typed that into your calculator, you're missing out. A good way to follow along in my lessons is anytime we do any number crunching, do it yourself for a couple of reasons. First of all, this is going to sound lame, but it's true. You do get a little tiny nerdy adrenaline rush, and I got the right answer as everyone else, and that is a bit of a motivator. Like, yay, you got the same answer as me? Yeah, cool. I know, it's low, but helps. But also, you're finding out if your calculator has any weird quirks. Oh, mine displays fractions differently. I have to unfraction everything. If you have a change button or something, you'll figure out how your calculator works and develop good habits, and you'll just get faster on your calculator, which Amy adds to more time on the test. So that's a win. Units, meters per second. B. B wants the bug's average velocity. Isn't that going to be the same answer as average speed? No, no. No, no. Ethan, I said that average velocity was the change in displacement over time. That bug from the previous page, what was the displacement? I think you were the one that gave it to us. The bug. You got the 14, dude. We did the displacement right after it. Yeah, I think so. I don't know. Yeah, do a bug. Example 1. I don't think it was 6, wasn't it? Oh, was negative? Yes, negative 6. Yes. Okay, so it's going to be negative 6 over, and how much time did this bug have according to this question now in example 6? Yep. Which is what? Is it negative 0.2? Double check me. Yeah? I can do some math in my head. Negative 0.2 even. Oh, technically I should go to 1 sig. Oh, I went to 1 sig fig. Okay. Units. How would you know? 2 ways. First of all, because it says that. But also, it's meters per seconds when distance is measured in meters, time is measured in seconds. Often the units will tell you if you're doing it right, because you'll kind of look at the equation. Yeah, that gives me those units. So meters per second. So here's what this means, okay? If all we care about is how many steps the bug is taking, it covered 14 meters in 30 seconds. That's its average speed. But because it ended up behind where it started from, negative 6 meters was the final displacement, its average velocity was traveling backwards. Of course it was, because it ended up behind from where it started from. This one up here is how most of you think. Most of you, for example, if you're wondering how fast something is going, well, how far did it get? Divide by how long it took. Kilometers per hour is the speed that most of you are familiar with. Distance over time. If average velocity is displacement over time, then what would be an equation for displacement and for time? Draw the line down the middle of the page like that. This equation here has 3 variables in it. V average, but V, D, and T. Rodrigo, that means that this equation has 3 separate equations in it. You can memorize all 3. Don't. I will teach you how to glance at an equation and rewrite it in your head into any form that we want. Some of you may have used this silly thing. I hate it. From some of your science teachers might use that. It's a gimmick, and it only works for certain types of equations. Kyle, we can do better. You can do better. It wants me to get the displacement by itself. See this equation right here? Okay? See where the D is? What side is the D on? Left side or right side? The left side is going to drop down like a domino because it ain't going anywhere. So everybody right now go VAV or VAV if you want to put the G on there. Let's go back to the right side. What else is on the same side as the D? What letter do you see? Where is that t? On the top or on the bottom? So that means it's dividing on the right-hand side. Hey, a t dividing on the right-hand side is the same as a t doing what on the left-hand side? How would you move it over? You're going to use your grade 8 and grade 9 math equation solving rules. Loud and proud. Say it again. You're right. Look up. Don't write this down, but look up. Don't write this down. Look up. So I can multiply the t over, and that would leave the d by itself. Don't write this down. But do you mind, instead of putting the d on that side, can I put the d by itself over here? Because that's where we're used to seeing stuff by itself. Write that down. There is another equation. That is the equation if you want to find the displacement and you know your average velocity and your time. Well, that was kind of cool. Amy, it also says it wants me to get time by itself. Amy, in this equation, where is the letter t in this equation right here? Ah, yuck. You awake now? Oh, wait a minute. In this equation, where is the letter t? Oh, and on the top? Let's get this t by itself. What side is the t on, left side or right side? The d, the left side, is just going to drop down like a domino. I'll rewrite it. And then next to the t, what other letter is right next to the t, Amy, my joy? What's the v doing to the t? Adding, subtracting, multiplying, or dividing? How do you know multiplying when there's no sign, when they're just next to each other? Okay, how would I move this v to the other side if it's timesing by the t on this side? How would I move it over? Yep. So are you saying that the d would have dropped down like a domino and there would be a v right there? And then that's equal to t, but Amy, do you mind? I'm going to put the t equals on that side because that's where we're used to seeing the thing by itself. That's another equation. Don't memorize it. I know I gave you probably one of these on your formula sheet. I doubt I gave you all three of these on your formula sheet. We're going to do a little actual number crunching now. Example 7. Here is your first physics word problem. I'm going to try and give you a couple of strategies. Josh, these are the strategies. If you don't know what to do, you're going to fall back on them. In fact, if you ask me for help and you haven't yet employed these strategies, I'm walking away. The first one is DULP. Don't write this down. We're going to include this in our notes later. The word DULP stands for draw a little picture. And especially in Physics 12 right now, because we're going two-dimensional, my students all know, Mr. Dueck, have you DULPed? No, I won't help you until you draw a little picture. The other one, don't write this down, we're going to include this in our notes later on, is DFIC. DFIC stands for list your data, that's what the D stands for, data. F stands for find a formula. I stands for insert the numbers. The C stands for crunch the answer, calculate the answer. I am big on giving you a method, Matt, that gets you writing stuff down. Now, many of you will get good enough that you don't need to use this anymore, but as soon as you run into a roadblock, you're going to hear me, Mr. Dueck, how do I do? Have you DULPed? Have you DFIC'd? No? Okay, I'm not going to help you until you start with that. So, Matt, look at this question, example 7. This is a physics word problem. Physics word problems are way easier than math word problems. I notice there's a part A and a part B, so I'm going to do that. Matt, what are they asking me to find in this question? V av equals question mark. Write that down. I always start out by saying, what are they asking me to find? Except I don't want to write, this is what they're asking me to find. So the shortest way I could think of to write that this is what I'm trying to find is to put an equal sign and a question mark. I figure that'll communicate to a marker or somebody else, this is the unknown value. Now, go back and you're looking for numbers. What's the first number that you see? What are the units next to that 350? Hey, what is that? Time? No. What is it? Yep. Now, it's kilometers, which I'm not wild about, but maybe, yeah, hold on. Keep reading. What's the next number you see? What? Oh, hours, you say. What's that a measure of? This is why I said it's worth memorizing what units go with what, because it cuts down on your thinking. Hours, what must that be? Time, you say. And this is hours. Now, I notice I have kilometers per hour. Normally, or kilometers and hours. Normally, Angeli, I would convert these, but then I notice part A wants the answer in kilometers per hour. These are the right units. I'm looking, Matt, for an equation that has a V, a D, and a T in it. There's 3 right above, right there. But read me the one that has the V by itself, please. I'm looking, ready, for an equation that has a V, a D, and a T in it. Look up. It's either this one or this one or this one. Read me the one that has the V by itself, please. Read me the one that has the V by itself, please. Do you read? Just no, don't even do that. Read it to me letter by letter. How about this? VAV equals, keep going. Yeah, you don't even need to read the names. We'll all figure out what you mean, and we're going to abbrev. And it reinforces the abrevs. VAV equals D over T. What's D? See, now we're at a plug and chug stage. 350 kilometers. T. And look, that will give us kilometers per hour. Go to your calculators, boys and girls. Ethan, what'd you get? I know, that's why I called on you. It's pretty obvious if you're not on your calculator, folks. If you're not on your calculator, I'm coming after you, so be aware. Ethan, what'd you get? 0.33. By the way, technically, 6.0, how many sig figs? Angeli. 2? 350, how many sig figs? Not 3. How many sig figs? 2. So technically I should go to 2 sig figs. I'm going to go to 3. This is why what I meant when I said for the rest of the year we're going to ignore sig figs. I'm not going to take marks off for sig figs, but I'll keep reinforcing them just to remind you what we should be doing. 58.3 meters per second. No. Kilometers per hour, Mr. Dueck. Good. Cool. Cool. Grace, what's B want me to do? Same answer in meters per second. Hey, this is a unit conversion. What's the first thing I'm going to do? What's the first thing I did for any unit conversion? Always. Write down what they gave me. 58.3 kilometers per hour. Oh, and no slanty fractions when you're doing unit conversions. You'll notice when I write units, I'll do kind of a slanty fraction, especially when I'm typing, because that's what I got in Word, but no slanty fractions when I'm doing a conversion. Grace, I want to get rid of kilometers. I want to get rid of hours. Which one do you want to do first? Pick. I missed that. So where is kilometers going to go in the next fraction? Kilo is 10 to the what? Ange, put your calculator down. I love that you're working ahead, but this one's, we're going to come up with a shortcut in just a second. So thank you for working ahead, but patience. Kilo is what? Did you memorize that? Or is it on your green sheet? Cool. Here's my only concern, and you did memorize it. In my last class, I had a kid say, 10 to the 3? It's on your sheet. You've memorized it and you're sure, or you're reading it and you're sure. We're looking at 10 to the 3. Right? Okay. Where does the 10 to the 3 go? Where the K is not, which in this case is on the top. That's meters per hour. Kenna, now I want to get rid of hours. Where is hours in my original fraction? On the... So where's it going to go, my next one? On the... Do you remember how many seconds are in an hour? It was exactly 3,600. Okay. So hours is going to go there. Seconds is going to go there. A 3,600 is going to go on the bottom because it's 1 hour is the same as 3,600. Don't get your calculators out just yet, but get your green sheets out. This one we're going to do so often, we're going to add it to our green sheet. By far, the most common conversion that you're going to do all year is either going from kilometers per hour to meters per second, because that's our preferred unit, or going from meters per second to kilometers per hour. It turns out, oh, the 10 to the 3 didn't show up, Mr. Dueck. Everybody look up, make sure you got the 10 to the, there should be a 10 to the 3 sitting on that 10 right there. It turns out when you times by 1,000 and divide by 3,600, that's the same as just dividing by 3.6. So don't write this down just yet. You're going to write this down when I'm done. On the bottom of the front page of your green sheet, don't start writing yet. Because again, I've tried to think what's the shortest way I can write this and still be clear. Here's what I'm going to suggest. Here's what I did. Near the left, I wrote kilometers per hour. Don't write yet. I left a space. I wrote meters per second. I drew an arrow pointing this way, and I said if I'm going from kilometers per hour to meters per second, it's divide by 3.6. And then I drew an arrow pointing that way. If I'm going from meters per second to kilometers per hour, it's divide by 3 times by 3.6. Write something on your green sheet on the front page, on the bottom, so that you can do this. And to be honest, about 90% of you will end up memorizing this shortcut because you're lazy and you get sick of looking it up, and we're going to use it fairly often. That's the only reason you really should memorize stuff, is you get sick of looking it up. And then once you've written that down, you can get your calculator and you can go, oh, don't go 58.3. Hit your answer button because you should have 58.33333 still stored on your calculator. So I think if you actually bring your calculator up and just hit divided by, it'll automatically put the answer button in there for you. 3.6. And Ethan, you know I'm coming back at you as well. So you're going to tell me what you got when you went answer button divided by 3.6. Think you're going to get something in the 16s? I didn't do that one in my head. I did that one from memory. What'd you get, Ethan? 2037, and that looks like it goes 037. 037 is my guess. So 16.2. 3 sig figs is pretty good. Meters per second. I like example 8. I like example 8. I like example 8. Example 8 is a nice question. Why would I say that? Did you hear me say it's going to be on the test? Or you're the kind of student that notices when a teacher mentions and emphasizes certain things, you pick up on that? Good, 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 good. I'm going to pause here. Thank you. That was a lot of me talking. But hopefully it's some terminology that's sinking in. We're going to pick up the pace pretty dramatically by the end of next week.